The following is an instructional video on how we can prove that the sum of the interior angles of a polygon is equal to 180 times n minus 2, where n represents the number of sides of a polygon. We begin with the interior angles of a triangle. We know that the sum of the interior angles of a triangle is equal to 180. So if we have a triangle ABC, the sum of these three interior angles is equal to 180. Next, we're going to look at the sum of a quadrilateral or a four-sided polygon. Notice that we can transform this quadrilateral into two triangles so that the sum of this triangle that we just formed plus the sum of this triangle is equal to the sum of the four interior angles of this quadrilateral. So 180 plus 180 is equal to 360. So the sum of the interior angles of a triangle is equal to 180, and the sum of the interior angles of a quadrilateral, is equal to 360. Let's extend the same technique to a five-sided polygon. Let's see how many triangles we can fit in a five-sided polygon. So I know I can connect this vertex to this vertex and form a triangle, and this vertex to this vertex and find. So in this manner, I've just created three triangles inside this five-sided polygon, and just like I did with the quadrilateral, I can add up how many triangles that are equal to 180 degrees I have. So I have 1 plus 2 plus 3. So 180 plus 180 plus 180, which is equal to 540. So for the triangle, we have the number of sides is equal to 3, and the sum of the interior angles is 180. For a quadrilateral, the number of sides is equal to 4, and the sum of the interior angles is 360. For a five-sided polygon or a pentagon, the number of sides is 5, and we have the sum equal to 540. Another way that I can express this 360 or the sum of the interior angles is based on how many triangles I have. Well, in the quadrilateral, I have two triangles, so I could say that I have 2 times 2 triangles, so times 180, which is equal to 360. And likewise for the pentagon, I have 3 triangles built in times 180, which is equal to 540. And we want to look at the relationship between the number of sides and the number of triangles that we're building. So with 5 sides, I'm building 3 triangles. With 4 sides, I'm building 2 triangles. We'll do one more just so that we can see the pattern. Notice that in a 6-sided polygon or a hexagon, we have n sides, and according to the pattern that we've been able to build, there are 4 triangles that I can build inside the hexagon, and each of those triangles have the sum of 180 degrees for all the angles. 180, 180, and you you can verify that, this is the only angle that I'm adding, plus this little piece plus this angle forms this entire angle of the hexagon, and then this little angle plus this little angle equals the entire angle of the hexagon. And same with this angle and this angle. This is the entire angle, and then these four angles add up to the entire angle of the hexagon. So I can confirm that I'm only looking at the interior angles of the hexagon. So we can see that in general, the relationship between the number of sides and the number of triangles that I can build is 2 less than the number of sides. So in general, if I have n sides of a polygon, n minus 2 is the number of triangles that I'm building. N minus 2 times 180 will give me the total sum of the interior angles. So for example, for a 20-sided polygon, I could find the sum of the interior angles equal to 20 minus 2 times 180. That's equal to the sum, or 18 times 180, which is equal to 3240. So the sum of a 20-sided polygon would have the sum of the interior angles of a 20-sided polygon would be 3,240 degrees.